All right, so today we are going to continue our study of rational functions. As I mentioned when we started this chapter, pretty much every chapter there's a progression, and this one is no exception. So the very first section we learned what is a rational function, what isn't a rational function by studying the easiest one of all, which was just the reciprocal function. Then in the next section, we took a look at the graphs, and on Friday we did a Desmos activity where we got to make different graphs to do different things. And then what we're going to do now in the next few sections, next couple sections, is we're going to learn how to do math with rational functions, which is leading us to the very end, which is where we learn how to solve equations that involve rational functions, okay? So maybe kind of a little bit weird that we're starting with multiplying and dividing. We're doing that before we are doing adding and subtracting. And the reason for that is rational functions are basically what? What is,
it's an equation.
what makes it a rational function?
It's rational. Why didn't you tell us to be funny?
Because I was hoping maybe, what did you say? Okay, a rational, rational function is a rational function when it is a quotient of two polynomials, okay? It's two polynomials that are being divided. And so basically, it's a fractional function, okay? And so the reason why we are going to learn how to multiply and divide first is because multiplying and dividing fractions is way easier than adding or subtracting fractions. How do you multiply fractions? If I asked you to do 1/2 times 3/5, what do? Nope, we're multiplying. You just go right across. You go 1 times 3 is 3, 2 times 5 is 10, and then you are done. What about if I asked you to do 1/2 divided by 3/5? What do you do in that case? Right, good. You multiply by the reciprocal. So it's basically a multiplication problem in disguise. You just have to rewrite the second fraction upside down, and then you do the same thing you do when you're multiplying. You just go 1 times 5 is 5, and 2 times 3 is 6. So that's easy peasy, okay? What do you have to do if you are adding two fractions? Okay, that's where you need to get a common denominator, okay? So that's a little bit more complicated, and it's especially complicated when your denominators are polynomials, okay? So we're going to work on, yeah, right, that was the, all right, I guess, whatever. We're going to work on the multiplying and dividing first because it's pretty simple, and then once you get the hang of that, we will up the ante a little bit and deal with multiplication and division. Okay, I mean, sorry, addition and subtraction. All right? Multiplication and division with fractions is really easy. Yeah, because you just multiply straight across. Whereas addition and subtraction, you have to do some front work before you can do that. You have to get a common denominator. Okay? All right, so let's give one of these a try. Okay? So this book is using some pretty fancy language. It says, write an expression that is equivalent to all that crazy stuff there. It's good for you to see that and to know that because that's the kind of language that they're going to use in this book. But basically all this problem is saying is, bless you, is simplify, okay? So all that big fancy jargon means is just simplify that expression, all right? And so the key to today and at least tomorrow, maybe even Wednesday, is when we're doing this with rational expressions, there are two steps. Each one must be done, and they must be done in order. The first step is to factor, and the second step is to cancel. Okay? You can't cancel unless you have factored. Okay? So you have to do those in that order. Are you ready? Okay. So let's take the numerator and factor it. How can I start factoring that? Not distribute the x, the opposite of distribute, which is factor out an x. Okay, so I can factor an x out of the top because each one of those terms has an x in it. And so that means I can pull one out of each one of those. And when I do that, then of course, all of the exponents go down by 1 because I've taken one out. What can I do to the bottom? Same stinking thing. I can factor an x out of the bottom also. And that leaves me that. Okay. And now that I have factored an x out of the top and I've factored an x out of the bottom, what can I do with those two x's? I can cancel them. Is that what you're going to say? Okay. So I have factored, and now I can cancel. All right? But wait. There's more. Yeah. There is more factoring to be done. So potentially, is that what you're going to say? Good. Potentially, there is more canceling to be done. What can x squared minus 5x minus 24 factor into? What? 8 and 3. Good. So I can factor that into x minus 8 times x plus 3. And I know that works because negative 8 times positive 3 is negative 24, and negative 8 plus 3 is negative 5. All right? I can also factor the bottom. What does that factor into? What is it? 8 and 9. Who's positive and who's negative? The 9 is positive, and the 8 is negative. And there we go. Since I have factored again, since these two things are the same, the x minus 8 on the top will cancel the x minus 8 on the bottom. And so that leaves me with x plus 3 over x plus 9. What's that? No. Okay, so this is really common mistake. And it drives me absolutely batty. Yeah, it makes me crazy. Yes, because I get this even in my calculus class, and I want our students want to go, okay, the x's cancel, and then 3 divided by 9 is 1/3. Okay, so I have a couple different ways to talk to you about that. First of all, canceling is what math operation? Division. Division is the inverse of what math operation? Multiplication. So you can only cancel when you're multiplying, right? So this is x minus 8 times x plus 3. This is x plus 9 times x minus 8. So since those are being multiplied, I can do the opposite and cancel them out. That's why we have to factor first, because that's turning it into a multiplication problem. This is addition. Okay, it won't cancel. If this was 3x over 9x, then the x's would cancel. Okay, so that's one way to think about it. Another way to think about it is, give me an x. Give me a number. Sorry, 2. If I plug 2 into here, what do I get on top? What do I get on the bottom? 11. Does 5 over 11 equal 1/3? No. Okay, so this doesn't work. There's one value of x that it would work for. 0. Okay, because if you plug 0 in for an x, then you kind of are canceling the x, right? But that's the only one that it will work for. So you can't do that. Yeah?
So say you can't factor that part right there.
Uh-huh.
But you just leave it.
Then you just leave it like that. Yeah, and it's kind of ugly, but that's what you would be stuck with. Okay? All right, will you try this one on your own, please? Thanks. That's an x to the 5th, yeah. I'll rewrite it here a little bit bigger. Okay, so try that on your own. factor first as far as you can go, okay? And then cancel. And you can factor and cancel and then factor and cancel, or you can factor, 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 and then cancel, cancel, cancel. Doesn't matter what order you do it. No, it's my computer's being super slow for some reason. There we go. Okay, Oliver, what'd you do first? What'd you factor out of the top first? Good, 3x cubed, because 3 goes into all of those things evenly. And they all have at least an x cubed in them. Okay? Good. What did you factor out of the bottom? Okay, same dealio. 2 goes into both of those evenly, and they each have at least a to the 4th power. So you can factor 2x to the 4th out of the bottom, and then that leaves you x squared minus 49. So I'm going to finish my factoring before I do the canceling. So where did you go from there? Oh, Gabby, really? Macy, I didn't pick you. What does x squared minus 6x minus 7 factor into? Okay, but let's go ahead and factor this. What are two numbers that multiply to be negative 7 and add to be negative 6? There you go. So that would be x minus 7 and x plus 1. Okay, this is a tricky one. X squared minus 49, what does that factor into? X what? X plus 7, x minus 7. Yeah, this is called the what? Difference of two squares. Good. So that factors into x plus 7 times x minus 7. Okay? Hey. Okay, good. So now we can do some canceling. So the one that obviously jumps out here is that the x minus 7's cancel. Okay? Also, x cubed is x times x times x, right? And x to the 4th is x times x times x times x. So what that means is cancel, 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 cancel. And so what you're left with is a 3 times x plus 1 on the top and a 2x times x plus 7 on the bottom. I am 100% certain, Mackenzie, that it was some sort of a slightly different situation where you're mathematically not able to do that. But you're good because it's all multiplication. Okay? So this is what this factors into. Okay, Isa, did you have a question?
How do you find the domain?
Okay, that's a great question. One of the things that this asks us for, Trevor, that the other problem did not, is what is the domain of this function, okay? So for that, I'm going to go to the factored form, and I'm going to ask you, based on what we did last week, where are the asymptotes, the vertical asymptotes of this function? Where does the bottom equal 0? At 0, and negative 7, and positive 7, okay? And so those are places in the graph where there will be a vertical asymptote, which means those are not in the domain. Okay? Does that make sense? Yeah. The places where the asymptotes are is where the domain isn't. Right. So in this case, the domain is x can't equal 0, negative 7, or positive 7. Yes, and the reason why it can equal those things that you named, Sophie, is because if I plug those into this function, I will get an answer. Okay? What would happen if I plugged 7 into this function? I would get a 0 on the bottom, and dividing by 0 is not allowed. And so that's why those are out. Okay? Okay, so what? Yeah. Yeah, anytime you just factor like a plain old x out, then that means 0. Yeah. All right, so this is basically the same as, like I said, another way of saying the fancy words that they said is to just simplify it. So let's just try this one more time, and then we'll see how this applies to multiplication. So what does 4 minus x squared factor into? 2 minus x times the quantity. We're going to stay with the 2's in front. 2 minus x times 2 plus x. Okay? So 4 minus x squared and x squared minus 4 factor the same way, but they just get flipped around to be opposite. Okay? All right, well, how about x squared plus 3x minus 10? What is it? X plus 5 and x minus 2. Huh. Yeah. Because this is 2 minus x and this is x minus 2. So they're almost the same. What's true about them? They got the same digits in them, but the signs are opposite. Yeah. In here, the 2 is positive, and here the 2 is negative. Here the x is negative, and here the x is positive. So guess what? I can cancel them, except that when they cancel, they don't equal 1, they equal negative 1. Okay? So yeah, so I need to put a negative. It doesn't matter which, on the top or on the bottom, okay? So if you have two things that are the same but they're completely opposite, 2 minus x, x minus 2, 4 minus x, x minus 4, they still cancel, but they cancel out to be the opposite things. Hold on just a second. Mathematically, the reason why this works is if I have 2 minus x, I can technically factor a negative 1 out of that and rewrite it as x minus 2, right? Because if I distribute this negative 1, I would get negative x, and then I would get plus 2. And then these two things would cancel, and I'd be left with this negative 1, which I don't really have to write, okay? Kylie, knock it off. Yes? What's that? Figure what out? No, factor and cancel. Doesn't get any easier than that. Thank you, Mason. All right, so let's talk about how this relates to multiplication. Okay, so most math books do this, and it's a little bit annoying because we've just been doing this sort of different kind of factoring, and now they're gonna. But whatever, we'll figure it out. So what's the product of, this is supposed to be easier, 2xy divided by z times 3x squared over 4yz. Okay, so just multiplying these two things together. Anybody see anything fun that can cancel? I heard it, what? Y. Did you say the y's? Oh, I thought you said, I thought I heard someone say the y's. Okay, there's a y on the top and there's a y on the bottom. So those can cancel. Okay? What else can cancel? The z's are both on the bottom. Okay? I can do the 2 and the 4. Yeah, so the 2 goes into here once. 2 goes into there twice. And then you wanted to cancel the z's, but the z's are both on the bottom. We can't cancel the x's because the x's are both on the top. And so now I just multiply together what's left. So what is x times 3x squared? 3x cubed. Nice job. What is z times 2z? 2z squared. Okay? And then I am done. Okay? So a little bit of an added step here. We're kind of technically factoring and then canceling, and then we're going to multiply them together. But you want to cancel before you multiply. Yeah.
Okay.
L.
Point where you cannot factor anymore.
Yeah.
Say if that was 3xy squared.
Yep.
And the bottom was still the same.
Yep.
You still multiply all of that.
Yep.
Okay.
Yep. You go as far as you can, and then you, yeah.
How long did it last?
What?
How long did it last?
This particular, like the chapter, the rational function. Oh, probably through Wednesday. Oh, finish the section tomorrow, quiz on Wednesday. Not a fan?
No, I really don't like it.
It's not, okay, okay. Do you, hey, Haley, do you like this even better? Look how excited, yeah, well, there you go, yeah. All right, so let's get really crazy with the cheese whiz here, okay? Let's do 5x over x plus 3 times x squared plus x minus 6 over x squared plus 2x plus 1 times x squared plus x over 5x minus 10. All right? So now we got all kinds of factoring that we can do. Okay, great question. The way you do the crossing with this is, since it's all multiplication, anything on the top cancels with anything on the bottom. It doesn't matter if it's here to here or here to here or this one to this one. Top and bottom cancel each other out. Okay? All right, somebody, yeah, but it's got to be diagonal, right? Okay, somebody raise their hand and tell me something that they can factor here. What you got? 5x and 5x. Okay, somebody else raise their hand, and I can't cancel 5x. I can't factor that, right? 5x is just 5x. X plus 3 is just x plus 3. Nothing I can take out of there. Yeah. Uh-huh. Top, middle. Okay. X plus 3 and x minus 2. Okay, perfect. Oh, I see what you're saying, but you caught yourself. Yeah, that's multiplication, so you can't. Yeah, okay, good. So the top middle factors into x plus 3 times x minus 2. What else can we factor? Crickets. Okay, good. What did you say? Oh, you want the next one. Okay, so Isa said x plus 1 and x plus 1 on the bottom, because 1 times 1 is 1 and 1 plus 1 is also 2. Yeah? No, actually it's better not to leave it as x plus 1 squared, because it's harder to cancel with the exponent. All right, and then the last two, what can I do with that? Yep, x times the whatever, factor out the x, so x times x plus 1. And then on the bottom, good, we can factor out a 5. Okay? All right, so now we have that completely factored as far as it will go. Like I said, anything on the top and anything on the bottom will cancel. Isa?
I think x plus 1 and
Okay, x plus 1 and x plus 1. Levi? Okay, good. Good old-fashioned numbers cancel just like they used to. Nothing's changed there. Mac? Okay, got an x plus 3 there and an x plus 3 there. What else we got? Yes? An x minus 2 and an x minus 2. Anything else? Nope, because those are both on top. Okay, so that's all the canceling that we can do. So then if I multiply what's left together, x times x is x squared. And what's left on the bottom? X plus 1. And remember, I cannot cancel this x and that x there because these on the bottom are being added. Okay, bah, so that's it. Okay? All right, good. No big deal. No big deal.
This is over